Okay guys, a very short video on differentiating polynomials. What can you expect from these kind of videos? Well, you can expect any kind of like animations or effort or anything like that. There's only one good thing about these videos: they're generally very short and they generally tell you just the things you need to know and nothing else. So don't expect pretty animation or, as I said, effort of any kind whatsoever. We're looking at differentiation of polynomials. Just a quick reminder of what a polynomial is. It's a piece of algebra with more than one power involved, and it's got to have integer coefficients. So if you look here, we've got y equals 3x to the power 4 plus 4x squared plus 6x plus 7. Prime example of what a polynomial is. Multiple powers, all the powers of integer coefficients. You've also got a constant, but hey, don't really care. What's the mechanism? If you've got a number as the power, that number gets lumped to the front and multiplied, and then you remove 1 from that power. Simple as that. So here we go, 3x to the 4 becomes 12x to the 3. 4x squared becomes 8x. You notice the x squared becomes 1. Well, when you've got just 6x, that will just become 6. You get x to the 0. And if you've got a number, it just vanishes. There are reasons for that, and we'll come to them in a few weeks, I guess. Two different types of notation. You've got y dy dx. Your other option is f of x, f dashed of x. There was actually another notation. There's generally 3 different types of notation. It's actually much more than 3. I take that back. The y dy dx, I think, is Leibniz. A guy called Leibniz invented it. Fx, f dashed of x, is Lagrange. And Newton's one is generally sadly forgotten, apart from in actual mechanics where they use it. So when we come to that, I'll show it to you, but they just mean the same thing roughly in this particular context. They actually don't quite mean the same thing. That's not true. But when we're talking about differentiation, we can use them interchangeably. But my advice to you is whatever one you've got, stick to it. So if you've got y, don't make your next line I've differentiated now as f dashed of x, right? They don't mean the same thing. I'm just going to reiterate that. One is a function notation, one is more kind of equation-y, graphy, so go with it as it goes. One other thing, just before I finish up on this, is sometimes it's easier, it's most of the times easier, to deal with questions in index form. So let's take f of x here. That is quite hard to differentiate as it looks now. But if I turn it into index form like this, it becomes a lot more easy to differentiate. You might want to return it back to its original form afterwards. So that's the only thing else really I want to talk about at this point. There's not particularly much on this. It's a very mechanical process. You do loads of them, you get good at them. Of course, it has uses, and uses will come in a different video. This is all about differentiation of polynomials, just the mechanics. So that's that. Bye.